Okay. Permutations and combinations. There are two different ways to calculate the results of a certain situation. Okay? On a permutation, the order in which things happen matters. On a combination, it's not important what the order is. Okay? So, figuring out which is which is the hardest part of this entire lesson, to be honest with you. So if the order is going to matter, it's a permutation. If it's not going to matter, it's a combination. One way, and they use the letters C and P to represent a combination and a permutation. And one way to remember it is the combinations are more complicated in the formula. Combinations and complicated, they both start with C's. All right? So that's one way I help my brain remember which is which. Let's go through this and see if we can figure out on these examples which ones are combinations and which ones are permutations. Remember, order matters if it's a permutation. Creating an access code for a computer site using any alphabet letters. What would you think? Wrong. Well, after you've picked one value, then there's only how many were we doing? 8. Then there's only 7 places left for the next alphabet letter. And after you pick the second alphabet letter, then there's only 6 places, and then there's only 5 places. So you're picking one, and that has an effect on the others, the other remaining choices, right? So that's where the order matters. So we would call this a permutation, because the order is going to matter. What about determining how many different ways you could elect a co-chairman and a chairman on a committee if you have 10 people to choose from? Permutation, because you have the chairman and then you have the co-chairman. Well, once you've picked one, they can't be the other one. You know, it's not equal. There's positioning, and therefore it's particular, okay? So this is also a permutation because the order does matter. You only get to have one chairman and you only get to have one co-chairman. What about allowing 10 new people to join your club when there's 25 to choose from? That truly is a combination because they're all going to be equal and it doesn't matter in what order I choose them. Whatever 25 I grab is going to be it. Okay? What about finding different ways to arrange a lineup for a batter on a baseball team? Permutation because order matters. Okay? Choosing 3 toppings for a pizza when there are 9 choices. Just a comment, I can pick any 3 and which one I pick first doesn't have any effect on what I pick second. So it's a combination. But it's not making you choose a first, second, or a third. You get to pick any 3.
But there's only 9 choices.
Right. But you can pick any 3 in any order and they'll still wind up on your pizza just fine. It's not going to affect. No, but on a computer access code there would be blank spaces to fill in. They're very specific where they go. On a pizza, it's going to be over the whole pizza.
Oh, now I get it.
Plus they ask you like when you throw a little bit combination. Boom.
Well, it's when order matters, it's definitely a permutation. Okay? And it just takes practice to get better at identifying these. Thank you. Can you make it? All right. Hang on. All right. All right, so if we have a combination, here's kind of some examples of combinations that might help to clear things up. Suppose you can invite 3 of your friends to go with you to a concert, and you're going to choose Jay and Ted and Ken. This is not any different than you choosing Ted and then Ken and then Jay, or any order, right? Doesn't matter what order you decide to choose them, they're all getting to go. That's kind of like the pizza toppings one. There, I get all 3 of them, okay? Now, it says, suppose you invite 3 friends and you have 5 that you're going to choose from. All right? And so you're going to write on a slip of paper all the names and then put them in a bowl. And then you're going to randomly choose the names from the bowl. If the 5 people are Jay and Ted and Cal and Bob and Ken, then you're going to write down all the possible ways that you could choose a group of 3 people. So you'd list, okay, it could be this person, this person, this person, this person, this person, this, but their order doesn't matter as long as you have all of the choices. And if you flip it over on the back, here are all of the possibilities. Maybe, I don't know, I wasn't there.
It's something similar to this.
Did you? Probably.
Yeah. Well, not kindergarten, but elementary school.
Yeah, okay.
But I remember doing this because I remember, like, you had red, yellow.
And how many?
What order
Yeah.
you can go in.
Yeah. So, yeah, all of your math generally builds. So hopefully we are drawing on something that's somewhat familiar. So these are all of the possibilities, rearranged in all the different ways we could have the combination of these 3 people. All right? But their order didn't matter as long as it was each one of them had an opportunity. Now, the formula in order to do this is right here. Now look at how many there are. 3, 6, 9. I have 10 different ways to organize these friends who are going to go to this concert. Mathematically, the formula looks like this. I'm using a C because it's a combination, all right? The N is going to represent the total number of people I have. The R is how many I get to choose, okay? And then you have this thing called a factorial, which is an exclamation point. That's called a factorial. And you might, just real quick on the front, when you see combinations, you might see them written like this as well. I need the combination of, once again, this is the total number of items, and this is what you're going to choose, how many you're going to pick. You might also see it written like this, the N and then the combination R. Same idea, this is the total, but I'm going to choose this many. Be comfortable with seeing it both ways because it just shows up randomly with different notations. So if you're going to fill this in and work it out, we have to know what a factorial means. Well, the factorial means you take the number and then you multiply by everything below it in order. So this is the total number of people I have to choose from, but I'm only going to get to pick 3. And the formula says the total number factorial, so the total number was 5 factorial, and then it's 5 take away 3, which is your total number minus your choices, times your choices, and they're all factorial. Now, the factorial means this. You have a 5. You have to multiply it by a 4, a 3, a 2, a 1. That's what a factorial does. The number and then everything below it all multiplied together. Here, you would have 5 take away 3, which becomes a 2 factorial. So that would mean 2 times 1. And then 3 factorial is 3 times 2 times 1. Kind of get it? All right. Here's the nice part about this. Yes, sir? Question?
For example, that pretty much 4 would go 4, 3, 2.
Uh-huh. Yep. The nice part about this is once you have them all written out, things that match can get canceled out, just like a fraction, right? So now we just multiply what's left. 5 times 4 is 20. 20 divided by 2 equals 10. And that was the number of choices that we saw when we wrote out all of the possibilities. It's kind of cool, isn't it? It's kind of cool. Yeah. Factorials are used quite a bit in algebra and algebra 2. You'll see a fair amount of them. Okay. So now that you have an idea of how it works, let's see if we can go back and work problems 3 and 5. Okay. Problem 3 was when I was voting to allow 10 new members to join a club, but there are 25 people who would like to join. So how many total do I have to choose from? I have 25 total to choose from. But how many can I pick? 10. So that's what it would look like if you were to set it up. And so remember the formula. And I'm going to start right here, and you're going to see why. Okay? If there's 25 to choose from total, that goes on the top, so I have 25 with a factorial. And then what's going to go on the bottom? A 25 minus 10 with a factorial times 10. Now, the C for the combination is a more complicated formula. All right? Just remember that. So now we're going to work this out. So I have 25 times 24, 23, 22, 21, 20, 19, 18, 17, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off, right? Okay. Yes, sir. You will need to do this on your assignment today. So you are going to need, no. I think 26 is the biggest number, possibly. No, it's 25 with the factorial. That means 25 times 24, 23, 22, 21. Yeah, till you get to 1. Okay, well, we're not done yet. Y'all stopped me before we got done. Okay, so that's just the numerator. Now let's look at the bottom. What's 25 take away 10? Okay, so I now 15. So I have a 15 factorial, so I'm going to go 15, 14, 13, 12, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Did I skip 11? I skipped 11 last time too. All right, 11. There it is. You skipped 12? Yeah, your brain, it's crazy how it works. Okay? So that's the 15 factorial, but now I have to do a 10 factorial. Times 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It doesn't really matter. Mathematically, multiplication doesn't matter. All right, now, once you get better at this, you'll be able to recognize things a little quicker that are going to cancel out. And you won't have to really write this much. Because right now, on this 10 factorial, you knew 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? So could you have like not written this because you knew it was going to cancel out with these? Okay, so sometimes you can take a little bit of a shortcut. But what else can I cancel out? Is there anything else I can cancel out?
The 11 through 15.
The 11, starting from 11 up to 15 here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the 11 through the 15 all got canceled out.
Got 15.
But now you really have to do the multiplication.
What?
Okay, so now we're going to take our calculator and multiply 25, 24, 23, 22, 21. 25, 24, 23, 22, 21, 20, 19, 18, I'm afraid I'm going to mess up, 17, 16, equals a really big, humongous number.
Yeah.
Okay, so that's my numerator. So 1.186167629 times 10 to the 13th power. Ma'am?
Why did you cross off
Because I had matching numbers on the top and the bottom, so I was able to cancel them out. Anything that matches the top and bottom, you can cancel out. It's like a fraction. Okay, simplifying a fraction is really all you're doing. So this is the numerator now. And then the denominator, let's see, so I have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I don't really know what that number is, but I got my answer, 3268760. What was this number? 30, what? What? 30 what? Holy moly Batman. 3628800, right? And there's your answer. No, that is simplified. This is simplified. There's nothing else to do to it.
Why did my third grade teacher teach me this?
All right. Let's try now. Let's try number 5. It'll be much shorter and much easier. Okay.
You lost me at that.
Okay, well then let's do number 5 and see if you can get it, okay? Because all I did was put these in the calculator and multiply them. So if you don't have a calculator, you need to get one.
No, I know what to do.
Okay? Well, you have to figure it out. All right? All right, let's look at number 5. Okay, number 5 on the front of the paper says, this was the pizza problem that you guys were arguing about a little bit. You get to choose any 3 toppings, but there are 9 choices. Okay, so this would look like what? 9C3. The 9 is factorial on the top. Then it's 9 minus the 3 factorial on the bottom, times 3 factorial. Okay. So we're going to write out our values, okay? On the top, you have a 9, an 8, 7, 6, 5, 4, 3, 2, 1. All of those are multiplied together. And on the bottom, what's 9 take away 3? 6. So I have to start at 6. 6, 5, 4, 3, 2, 1. That's just the part in the parentheses, right? Then I have to do the 3 factorial. So that's a 3, a 2, and a 1. Are you with me?
Yes. Say it again about.
Okay. The 9 minus 3 is the 6. So 6, 5, 4, 3, 2, 1 represents the part that's in the parentheses. Then you have a 3 factorial, so it's got to go a 3, a 2, and a 1. Okay, now we're just going to cancel off things that match. The 3's, the 2's, the 3's. Okay, so 1, the 2, the 3 there. And then I can't cancel out this 1, 2, 3, but I can go the 4, the 5, the 6 here, the 4, the 5, the 6 here. Because you didn't have them on the top anymore. You already canceled them out once. You can't cancel them again unless you have something in the numerator that would allow you to cancel out a second time. Okay? So now you just multiply together. You should have a 9 times an 8 times a 7 over a 3 times a 2 times a 1, essentially. Okay? So let's see. 9 times 8 times 7. So 504. How about you just divide it? It should divide nice. So you would have 84 different ways to take those 3 toppings if there were 9 to choose from. That's closer to what your homework is going to be, okay? Shh, you guys hush now. Yes, ma'am? It's okay, the n is always, your first value is always the total that you get to choose from. The possible choices. And then the second value, the r, is what you actually need to use. Generally the smaller of the two numbers, okay? All right. Now are you fairly comfortable with that one now? All right, now we're actually going to go to the easier one, which is the permutations. They're easier, and at the same time, they're a little bit more complicated.
Can I just stick with combination?
Oh, ma'am?
But not exactly. Not exactly. Like this. What was the second? Like the all.
There we go. Okay. Okay, now please pay attention. The permutations on this part, notice the symbolism in the formula. It all looks very similar. All right? It's pretty much the same concept as to where everything goes. But when you think about it, now order is important. And so my numbers might be smaller because it matters what I'm putting where now. It's not just random. Okay? So in this example, we are going to be running a race, and there's 4 people in the race, but we're only going to give trophies to the first 3. And the order matters. First place, second place, third place. So because it's in order and it matters because if was Kim up there? Yeah, if Kim gets first place, then she can't get second place, can she? So that's why the order matters. And when order matters, you're going to use a permutation. So here are all of the possibilities of each one of them getting a first place, and then a second place, and a third place. So notice how many choices there are there. That's significantly fewer than the pizza problem kind of thing, right? Because the order was important. You're not going to have quite as large numbers most of the time. So there's a total of 24 orders, different ways that they could end this race. Notice the formula now on the permutation. I can't hear you. I can't hear you. It can be any of them.
There were 4 people.
There's 4 people, but only 3 get to win. So on each combination, there's going to be somebody left out. Okay, so if we look here at the permutation formula, pay attention up here, okay? That'd be helpful. All right. The formula looks like this. Notice the N and the R still represent the same thing. N is the total number of choices, things you get to choose from, and R is what you're actually going to pick or what's going to occur. So you still have the factorial, and you still have, I have this many, but I'm only going to choose this many on this factorial. Notice it's a simpler formula. Okay, so the combination is more complicated. The permutation is simpler. So we had 4 people on the race. We had the 4 people running, but only 3 people could win first, second, or third, right? So that's why it's a P3. When you do the formula, you have 4 factorial as being 4, 3, 2, and 1. And on the bottom, when you subtract the 2 values, you get just a 1. And notice your answer is 24. So that one's pretty easy. Let's go back and do numbers 1 and 2 from the notes like it says. Okay, I'm flipping mine over. Number 1, this was the alphabet. Number 1, creating an access code for a computer site using any 8 alphabet letters. So I need to choose 8, right? 8 letters. I need to choose 8 letters. How many will there be to choose from? 26. There's 26 letters in the alphabet. So how would I write this one?
26.
26 P8. Okay? Right. So 26 is what I'm going to have on the top. And then 26 minus the 8 factorial is what would be on the bottom. Now that you're kind of familiar how this works, what's this answer going to be here? 18. So it's going to go 18, 17, 16, 15, 14, correct? Knowing that now, knowing that, my top value, let's see, I'm going to give myself some space here. 26, 25, 24, 23, 22, 21, 20, 19. Do I have to do 18 on down? No, because on the bottom, I'm starting with the number 18, 17, 16. So that's all going to be cancel each other out, right? So all I have to do now is this part. Does that make sense? Okay. It wouldn't have made sense in the beginning, so you're getting there. All right, so now we do have to do the calculator. There's no doubt about it. 26, 25, 24, 23, oopsie, times 22, 21, times, don't mess me up now, 19. Woo! Okay. 6.299098 times 10 to the 10. That's a couple of choices. That's a couple of choices, right? That would be your answer.
Yeah, because you have no bottom.
Yeah, we have no denominator, so you're finished. Yeah. Okay. How are you doing? Kind of okay? All right, let's try the next one. What other one did they want us to try? Number 2. Yes, sir? How about we just get done with the notes first, okay? Yeah, well, you'll find out in a minute. Let's stay focused on what we're doing first. All right, on number 2, you have a chairman and a co-chairman. Okay, and it says I have 10 people who want that position. So how would you write this one? 10p2, right? So 10 factorial over 10 minus 2 factorial. So 10 minus 2 factorial makes an 8, right? So it's 8, 7, 6, and this is going to be 10, 9. Oh, do I have to keep going here? No, because from the 8 on down, they're going to cancel each other out, and you would have 90 choices, 90 different combinations, or actually permutations, correctly. 90 permutations that could occur. Okay? Any questions? Yes, sir. Isaiah?
So, can we get your piece smaller?
It didn't. I just kind of squeezed it in there. Sorry. Doesn't matter. Yes, sir?
Why, aren't you putting, how do you put a number on the outside of the purpose? It's like, then you did that for so much more.
What?
10 minus 2 is
Yeah?
on the other, on the front sheet, there was like another number.
Right.
So you split one.
They're different formulas. The combination is a different formula than the permutation. The combination also had something here with a factorial on it.
Oh, so only the combination was not.
Correct. They're different formulas. Yeah. Yeah, look carefully at them, okay? All right, so I'm going to pass out the notes, and we're going to kind of go through whether they're combinations or permutations to get you started, okay? And that'll kind of help a little bit.
I like to see what
Some people are not too fond of this.
There's more notes.
Yeah, well, this is the worksheet.
Oh, okay.
Sorry. It's the worksheet. We're going to go through it.
Good. I thought you had more notes to pass out.
No.
I was like, oh my goodness. I feel like I'm gonna have to do that to be honest.
All right, let's get focused back again. Here we go. All right, here's your worksheet. Let's talk about what's what, because it does matter. Okay. What do you think number 1 should be?
Permutation.
Okay, I have 7 people that are at the swim meet, but I have a gold, a silver, and a bronze. It's a permutation because the order is going to matter. So maybe just put a little P right there. Okay, number 2. How many different committees with 3 people can be chosen from a group of 9? Combination. The order does not matter. A coach has to show how his lineup of 5 starters for a team of 12. Permutation. Permutation. Order matters in a lineup. You want your certain people in certain positions, okay? How about John is going to make some juice and he's got 5 different fruits and he wants to use 2 fruits at a combination. He doesn't care which fruits he uses in what order. Okay? So it's a combination. Number 5, a 4-letter password. Permutation. Okay? Number 6, a chairman and a co-chairman. Permutation. Number 6 is a permutation because you have a position of co-chair and chairman. Okay? Number 7. There are 25 people who work in an office. 5 of these people are selected to go to a conference in Florida.
Permutation.
Okay, does it matter what order the people go to in there? No, so it's a combination. It's a combination. But now I have 25 people who work in an office, but they're going to go to 5 different conferences.
Permutation.
This one matters, because if they go to one conference, they can't go to the other conference. So it's a permutation. On number 9, John has a serial number on his bicycle. There are 6 different digits.
Permutation.
Permutation. Okay. Yep. Number 10. How many different 7-card hands can be chosen from a standard 52-card deck? Combination. Good job. You're getting the hang of this. 112 people bought a raffle ticket to enter a drawing for 3 prizes. How many ways can the 3 names be drawn for a first, second, and third prize? Permutation. Okay, a disc jockey has to choose 3 songs for his last few minutes. If there are 9 songs that he feels are appropriate for that time slot, how many ways can he arrange to play the 3? It's a permutation, actually. Yep.
What was the keyword? Arrange.
Okay, you're on. Keep it up. It's fine. You're being recorded, so it's great. Okay. No. So keep those in mind. All right. Look. I want you to put a circle around numbers 10 and 11. I want you to not do those until the last 2 problems. And if everyone finishes in class today, which you might be able to because we'll go to lunch here in a second and then come back and have an hour's worth of time to get your homework done. If everyone finishes, I'll show you the shortcut at the end of the hour. Otherwise, I'll show you a shortcut at the beginning of the hour tomorrow. Okay? So either skip those 2 if we don't get a chance to get there, or we'll all learn it at the very end of class today. All right? Just depends on how everybody works. Did we do a Mad Minute last week?
No.
Okay, so we need...
Oh. It's Isaiah.
Okay, the question was, did we do a Mad Minute? Okay, so... All right. Then we